Hello students, myself Arpita Bhatia. Today I am going to deliver a topic on priority scheduling, preemptive and non-preemptive. Okay. So, priority. Out of all the available processes which are in the ready queue, how to decide to allocate CPU to which process, we will decide on the basis of priority. Okay. Highest priority process will get the CPU. If there is a numerical, if it is given in the numerical that lesser the number and higher the priority, then we will allocate CPU to that process. Basically, priority is of two types, static and dynamic. Okay. Static means priority of a process remains unchanged throughout the execution, and dynamic means priority of a process changes after a certain interval of time. Okay. As I have earlier told you in the previous video that there are two types of scheduling, preemptive and non-preemptive. Preemptive and preemptive scheduling, after a certain interval of time, CPU is allocated to a new process on the basis of FCFS or on the basis of burst time or on the basis of priority. But in case of non-preemptive, we cannot remove a process from the CPU until and unless its execution has completed. So first we'll start with priority non-preemptive scheduling. Okay. In the numerical, if it is given that lesser the number and higher the priority, then you will solve this. If not given, then by default we can take that lesser the number, higher will be the priority. Okay. In the numerical, priority of a particular process will be given, arrival time and burst time will be given. You have to calculate completion time, turnaround time, waiting time and response time. Here we'll start from this. Priority. Process, priority, AT means arrival time, VT will be burst time. Processes are given. Priorities are given. Arrival time of each process is given in a numerical. Okay. Here, priority is not given in the question. Here, how to, which process is to assign the CPU is not given. So, by default, we will take lesser the number, higher will be the priority. Okay. First of all, we will draw a Gantt chart. Okay. As it is priority non-preemptive, so a process will run till its burst time is given. So first of all, check out the process having least priority. P7 process having highest priority, lesser the number, higher the priority. So P7 process has highest priority, but its arrival time is 10 unit of seconds. So CPU cannot remain idle until 10 unit of time. So we will check out for the process, check both points, priority and their arrival time. Since P1 is the process, its arrival time is 0. So instead, its priority is less than P7, but its arrival time is 0 unit of second. So CPU will not remain idle in this case. So P1 will execute it till 8. Okay. So we will cut this. Okay. Next, at 8 unit of seconds, see which process has arrived. All the processes arrived except P7, but out of all the processes, which is having highest priority, out of all the processes, P5 is having highest priority. Tick. So P5 arrival time is 6, already come in the ready queue. Its priority is 2. For how much time it will execute? For 5 unit of seconds. Okay. Tick. Next. At 14, which process come now? P7 process has already come in the ready queue. So we will execute P7 process for how much unit of seconds? For this unit of seconds. It is 5. Sorry. It is P7 for P7 execute for 1. It will execute for 1 unit of seconds. Okay. P5 is also done. Now, all the processes has come in the CPU. यार चुपर हो रहा है. 8 2 4 1 6 6 8 2 4 1 6 5. So here P1, P5 and P7 process has already executed. Now how many processes remain left? P2, P3, P4 and P6. All the processes are available in the ready queue. So how to decide which process is to be allocated to the CPU? On the basis of their priority. P2, priority of P2 is 4, P3 is also 4, P4 is 5 and P6 is 6. Out of these 4 processes priority, which process has higher priority? P2 and P3. So there is a tie. Okay. 4 and 4, both priorities are same. So we will decide on the basis of their arrival time. Arrival time of P2 is lesser than P3. So we will execute P2. For how much time? For 2 units of time. So P2 is also executed. Next, P3 is in the ready queue. So we will allocate CPU to P3 for how much burst time? For 3 units of time. P3 for 4 units of time. Sorry. For 4 units of time. Next, 2 processes are left in the ready queue, P4 and P6. Since P4 has higher priority than P6, so we will allocate CPU to P4 for 1 unit of time. P4 for 1 unit of time. Next, last process remaining is P6. P6 will be executed for 5 units of time. 27. As in the earlier video, I have told you that how to check that this last completion time has been verified with the help of total burst time. 8 plus 2, 10, 10 plus 4, 14, plus 1, 15, plus 1, 10 with the help of burst time. 8 plus 2, 10, 10 plus 4, 14, 15, 15 plus 6, 21, 21 plus 6 will be 27. So, our numerical has been verified with the help of this total completion time. Now, completion time of P1 For the calculation of completion time, you have to look at the right side of the Gantt chart. Okay? For P1 completion time is 8, for P2 17, for P3 21, for P4 22, for P5 8, for P5 14, for P5 14, for P6 27, and for P7 it's 15. 8, 17, 21, 14, 27, 15. Okay. Now turnaround time. Turnaround time will be the difference between arrival time and completion time. So this one, 8 minus 0, 8, 17 minus 1, 16, 21 minus 3, 18, 22 minus 4, 18, 14 minus 5, 9, 27 minus 6, 21, and 15 minus 0 will be 15. 15 minus 1 will be 14. Now waiting time. Waiting time, turnaround time minus burst time. 8 minus 8, 0. 16 minus 2, 14. 18 minus 4, 14. 18 minus 1, 17. 9 minus 6, 3. 21 minus 5, 16. And 14 minus 1 will be 13. 14 TAT minus burst time. Okay. Next, response time. First time a response has been given to the process minus arrival time. Response time for P1 0 minus 0, 0. For P2 15 minus 1, 14. For P3 17 minus 3, 14. For P4 21 minus 4, 17. For P5 8 minus 5, 3. For P6 22 minus 6, 16. For P7 14 minus 10 will be 4. So, how will verify that our numerical is correct? With the help of this one, waiting time and response time will be equivalent to each other, hence our numerical is correct. So, we will solve this using preemptive priority non-preemptive scheduling. Now, our next topic will be priority preemptive scheduling algorithm. Priority preemptive scheduling algorithm. I am writing this numerical, so we will solve process then arrival time, then priority. It will be given in the question. If it has not been specified in the question that lesser the number, higher the priority, then you can take by default that lesser the number, higher will be the priority. If some process has given priority 1, it means it has highest priority than the other processes. Here arrival time is given 0, 1, 3, 4, 5, 6, 10. Priority is given 3, 4, 4, 5, 2, 6, 1. So, here it is not specified in the question that lesser the number, higher the priority. So, I am taking by default lesser the number, higher will be the priority. Burst time will be given in the question 8, 2, 4, 1, 6, 5, 1. First of all, we will draw a Gantt chart. So, find out a process having highest priority. Which process is highest priority? P7. Okay, lesser the number, higher the priority. But it will come at 10th unit of second. So, CPU cannot remain idle for that much of time. So, we will decide on the basis of arrival time to start allocating CPU to a particular process. Here P1 comes at 0 unit of time. For how much time P1 process will be allocated to CPU? For until next process came for that unit of time. For 1 unit of second, since P2 came for 1. At 1, which process has come in the CPU? Which process has been come into ready queue? At 1, P2 come. But compare between P1 and P2, P1 has higher priority than P2. So, still P1 will be allocated to the CPU for how much unit of time? Until the time of next process came. Next process will come at 3. So, we will allocate CPU till 2 unit of seconds. 1 plus 2 will be 3. At 3, which process has been come into the ready queue? P3 came. But still P1 has higher priority than P3. So, still CPU will be allocated to P1. For how much unit of seconds? For 1 unit of seconds. At 4, which process has come? At 4, which process has come in ready queue? P4. But now compare between P1 and P4. P1 has higher priority than P4. Since lesser the number, higher will be the priority. So, P1 will continue to run till how much unit of seconds? Till next process arrive. Next process will arrive at 5 unit of seconds. So, we will run P1 till 5 unit of seconds. At 5, which process has come into the ready queue? P5 has come. So, now compare between the priorities of P1 and P5. P5 has higher priority than P1, since lesser the number, higher the priority. So, we will stop allocating CPU P1 and we will allocate CPU to process P5. So, for how much unit of time? P1 has run 1, 1 plus 2, 3, 3 plus 1, 4, 4 plus 1, 5. So, 8 minus 5 will be 3. Still 3 unit of time will be required by the P1 process to execute. So, we will run P5 for how much unit of seconds? Till next process arrived. For 1 unit of seconds. Now, at 6, which process came? At 6, P6 has come into the ready queue. But still, compare between the priority, P5 has higher priority than P6. So, we will continue running to the process P5. For how much unit of seconds? Till next process arrive? For 4 unit of seconds. Okay. So, for how much unit of time P5 is run? For 4 plus 1, 5. P5 is run for 5. So, still 1 unit of time is remaining by the process P5 to be executed. At 10, P7 process has come into the ready queue. Now, compare between the priority of P5 and P7 because P5 is still wants to allocate CPU for 1 unit of seconds for its execution. So, we will compare between P5 and P7 since priority of P7 is higher than P5. So, we will allocate CPU to P7 for how much unit of seconds, as it requires only 1. So, we will allocate CPU to P7 process for 1 unit of seconds. Now, at 11, all the processes has come to the ready queue. So, now to decide which process has been allocated to the CPU for its execution. Out of the available processes, P1, P2, P3, P4 and P5 and P6. Which process has which process has highest priority? P5. Okay. So for how much unit of seconds it will be allocated to CPU? For 1. So P5 for 1. P5 has executed. P5 and P7 has finished its execution. Now out of the available process, we'll check again with the help of priority. P1 has 3, P2 has 4, P3 has 4, P4 has 5 and P6 has 6. So out of the available process, which process has highest priority? It is process P1. P1 will require how much unit of time? 3 unit of time to be executed. After such time, all the processes are available in the ready queue, just starts execution until their burst time has been completed. So P1 will be executed for 3 unit of seconds. Now P2, P3, P4 and P6 are remaining. P2, P3, P4 and P6, P2 and P3 has higher priority. So we will compare on the basis of their arrival time since there is a tie. So P2 will be executed on the basis of P2. P2 will be executed first for 2 unit of seconds. To break the tie in the priority, we have to apply FCFS scheduling algorithm. Then will came P3 for how much unit of time? For 4. Now P4 and P6 two processes are remaining. So P4 has higher priority than P6. P4 will run for 1 unit of time. Now P6 will run for 6 unit of time. It is 28. P6, oh 5. It's 5. So it will run for 5 unit of seconds. P6 has 5 burst time. So all the processes have been allocated to the CPU, right? Now we'll calculate their completion time. Completion time, we will find out completion time by looking at the right side of the Gantt chart. For P1, completion time is 15. For P2, it's 17. For P3, 21. For P4, 22. For P5, 12. For P6, 27. And for P7, it will be 11. Right? Now we'll find out turnaround time. It will be CT minus AT. 15 minus 0, 15. 17 minus 1, 16. 21 minus 3, 18. 22 minus 4, 18. 12 minus 5, 7. 27 minus 6, 21. 11 minus 10, it will be 1. Now we'll calculate waiting time. Turnaround time minus burst time. Burst time, original, whatever is given in the numerical, not here which we have find out. 15 minus 8, 7. 16 minus 2, 14. 18 minus 4, 14. 18 minus 1, 17. 7 minus 6, 1. 21 minus 5, 16. And 1 minus 1 will be 0. Now response time. First time a process has assigned CPU minus arrival time for P1. So for response time, you have to look to the left of the Gantt chart. For P1, first time response has been given at 0. 0 minus 0 will be 0. For P2, first time response has given at 15. 15 minus 1, 14. For P3, first time response has given at 17. 17 for P3. First time response has given at 17 minus 3, 14. For P4, first time response has given at 21, 21 minus 4, 17. For P5, first time response has given at 5, 5 minus 5 will be 0. For P6, first time response has given at 22, 22 minus 6 will be 16. And for P7, first time response has given at 10, 10 minus 10 will be 0. So, look, for preemptive scheduling algorithm, waiting time and response time will never be equal to each other. So we can verify with the help of this. If it is given in the numerical, calculate average turnaround time, then simple, just calculate with the help of this formula, total turnaround time divided by the number of processes in the given in the numerical. If you have given to calculate the average waiting time, just go with the formula total waiting time divided by the number of processes. Okay, that's all for all. Thank you.